Welcome to Agron Infotech. In this video you will learn how to carry out analysis for two-way repeated measures ANOVA using RStudio. The video will include description of the design, analysis of variance for two-way repeated measures, mean comparison or separation tests which will include SNK Test and Kruskal-Wallis Test. A two-way repeated measures ANOVA compares the mean differences between groups that have been split on two within subject factors. These factors are also known as independent variables. Two-way repeated measures ANOVA is also known as two-factor repeated measures ANOVA, two-factor or two-way ANOVA with repeated measures, within subjects ANOVA. A two-way repeated measures ANOVA is often used in studies where you have measured a dependent variable over two or more time points, when subjects have undergone two or more conditions. The primary purpose of a two-way repeated measures ANOVA is to understand if there is an interaction between these two factors on the dependent variable. You should also know how to identify a two-way repeated measures ANOVA from mixed ANOVA. Mixed ANOVA is very similar to two-way repeated measures ANOVA because both tests involve two factors. In a mixed ANOVA, subjects that undergo each condition are different. Whereas in two-way repeated measures ANOVA, same subjects undergo both conditions. The data file which will be used here for analysis contains subject ID, condition, time interval, and response variable. Here subject ID represents the subjects or individuals used to record the response variable measurements. These subjects have a condition where male and female individuals were used. The response variable measurements were recorded at 4 different time intervals. In this data set you can see the same subjects were repeated to record the response variable at different time intervals rather than using different individuals. As same subjects were repeated, so we shall proceed with two-way repeated measures ANOVA in RStudio. Save the data file in CSV, delimited file format. Use read.csv function to import the data in RStudio. I often use head function to see how RStudio read the data set. You can also use structure function to see the nature of the variables. Use attach function to attach set of objects or data components. This will ease while evaluating the data by simply giving the names of the data components. Let's proceed with analysis of variance to see how the response variable changes as the function of condition and time applied to each participant. To fit an analysis of variance model, use AOV function. The function is same as used in two-way ANOVA with only difference in error argument. Here you need to define error as ratio between subject ID and interaction of group and time factor. For denominator you can also use group, time, and interaction term combined with plus sign. Now see the results using summary function. The error function has decomposed the residuals into subject ID and group interaction, subject ID and time interaction, three-way interaction of subject ID, group, and time. This decomposition of error term considerably reduces the residual source of variance for the calculation of F value. The results indicate the effect of main factors as well of interaction is non-significant on response variable. However, in case if you get significant effects, then you can proceed for mean comparison test. Now let's compute mean comparisons to observe the differences between main and interaction effect. First, I shall use student Newman-Cool's test to see comparisons in main and interaction terms. SNK test is derived from Tukey, but it is less conservative. Tukey test controls the error for all comparisons, where SNK only controls for comparisons under consideration. To apply SNK test, first you need to load the library Agricoli using require function. Before using SNK.test function, first define error degree of freedom and error mean square value that will be used in this function. To get error degree of freedom, use df.residual function where use within component of ANOVA model. To get the error mean square value, use the ratio of deviance from within ANOVA model component and error degree of freedom that is obtained earlier. To apply SNK test, use SNK.test function. This function requires y argument that specify the response variable, TRT argument that represents the treatment factor variable applied to each experimental unit as group and time in this example. DF error and MS error represents degree of freedom and mean square for error term as determined earlier. Alpha shows the significance level. Default value is 5%. Group arguments specify the formation of treatment groups. True value for group will result in treatment groups with lettering. False value for group will provide information regarding comparisons between treatments. Using print function will show the results. The SNK test prints different components, which includes statistics of the ANOVA model, parameters of the design, SNK critical range table, statistical summary of the response variable, comparison between treatments. This will only result when you use false for group argument. Formation of treatment group. This will only result when you use true for group argument. For mean comparison of second factor, use group in TRT argument in previous SNK.test function. For interaction mean comparison, use concatenate function to represent the interaction term in TRT argument in previous SNK function. You can also use Kruskal-Wallis test for multiple comparison of means. For this, use Kruskal function, which requires same arguments except the error degree of freedom and error mean square used in previous SNK function. One additional argument is p-adjustment that requires method that will be used for adjusting p-values. You can use one of these methods for p-adjustment. None value for p-adjustment is t-student. For second factor mean comparisons, use time instead of group in TRT argument in previous Kruskal function. For interaction mean comparison, use concatenate function to represent the interaction term in TRT argument in previous Kruskal function. In the next tutorial we will see how to plot bar graphs for individual factors and interaction term with standard error bars. I hope this video will help you to carry out two-way repeated measures ANOVA. Please comment below if you have any questions.